Good day to you all. Welcome to the ninth lecture of Magnetic Compounds online lecture series. Today's topic will be deviation due to induced magnetism. Let's begin. Let's do some small recap. We already know that on board ship we have got two types of magnetism. One is permanent magnetism, another one is induced magnetism. These induced magnetism are susceptible to soft irons, and on board ship we have got thousands of soft iron. However, these are the following soft iron which impacts our magnetic compass most. Among those soft iron, the most important soft iron is fore and aft continuous HSI, athwartship continuous HSI, VSI forward or above the compass, VSI with the pole above or below the compass. And we have already know that from the previous slides, this fore and aft continuous HSI induced by jet acts in the forward and aft direction and causes some deviation. Athwartship continuous HSI induced by H acts in athwartship direction and causes some deviation. VSI induced by jet forward or above the compass acts in fore and aft direction, causes some deviation. And VSI with the pole above or below the compass acts in deck to keel or keel to deck direction. When the vessel is upright, that VSI with the pole above or below the compass will not create any deviation, right? And we have seen that when the vessel is on 00 degree or 180 degree course, that time fore and aft continuous HSI become fully induced, and when the vessel is 045 degree or 225 degree, that time it become partially induced, and when the vessel is 090 or 270 degree course, that time it is not induced at all. Why? Because the fore and aft continuous HSI doesn't have any length or breadth, any breadth or depth. It has got only length, so it will be induced lengthwise, right? So now as this fore and aft continuous HSI is induced, let us see how this fore and aft continuous HSI will affect our compass needle. When the vessel is on, we have got a vessel here. These vessels is kept on different heading. It is 00 degree, 045, 090, 135, 180, 225, 270, and 315 degree courses, right? And our magnetic lines of force is going in this direction. So from this picture you can see that the when the vessel is on the 00 degree course, that time it will have some blue pole on the stern, right? And when the vessel is on the 180 degree course, that time it will have a blue pole at the forward, right? Why? Because it is a induced magnet, right? So let us see what happens for different heading. What will be the impact of this fore and aft HSI to this compass needle? When the vessel is on the 00 degree heading, you see we have got blue pole at the stern and red pole in the forward, and there will not be any deviation at all, right? However, when the vessel is on the 045 degree course, you see this red pole will deflect that red pole of the compass needle, and it will have some deviation. And when the vessel is on the 090 degree course, there will not be any deviation because there is no induced HSI. And when the vessel is on the 135 degree course, that time there will be some deviation. Again, when the vessel is on the 180 degree course, though the pole has changed, but there will not be any deviation, right? Because these poles are fully aligned with compass needle. However, when the vessel is on the 225 degree course, that time there will be some deviation, and the vessel is on the 270 degree course, there will not be any deviation. Finally, when the vessel is on the 315 degree course, there will be some deviation. Now if we take this reading, like for 00 degree, 0 deviation, for 045 degree, some in the, that means in the northeasterly heading some deviation, right? Westerly deviation. For easterly course, no deviation. For southeasterly course, there will be some easterly deviation. For southerly course, no deviation. For southeasterly course, there will be some easterly, there will be some westerly deviation. For 270 degree course, no deviation. And finally, for north to easterly course, we have got some easterly deviation, right? If we take this reading and we create a graph, the graph will look like that, right? So what is this step, this graph called? This graph called is sine 2 theta curve, right? So from this curve and from this slide, we understand that this 4.5 continuous HSI induced by jet follows a sine 2 theta curve, right? And if we want to get the properties of this curve, or if we want to get the properties of the deviation due to the induction by jet, induction by H into the continuous 4.5 HSI, we can tell that deviation is quadrantal, right? And it changes its name in every quadrant. And deviation varies as sine 2 compass course, and maximum deviation occurs in intercardinal heading, right? Now let us look to the Edwards ship HSI. We have already seen this slide before, and we know that when the vessel is on the 090 degree course or 270 degree course, there will not be any deviation, right? And when the vessel is on the partially induced 045 degree or 135 degree or 225 degree or 315 degree course, there will be some deviation, right? Because it will be partially induced. And when the vessel is on the 00 degree course and 180 degree course, there will not be any deviation at all, right? Now we see what will be the effect of this Edwards ship continuous HSI on the compass needle, and right. So when the vessel is on 00 degree heading, that time we will see that there is no no Edwards ship HSI. That means no no deviation, right? However, when the vessel is on the 045 degree course, there will be partially induced HSI, Edwards ship HSI, and there will be some deviation. And when the vessel is 090 degree course, there will be fully induced Edwards ship HSI, but that fully induced Edwards ship HSI pole will be aligned with the compass needle, so there will not be any deviation. However, the directive force can increase or decrease, right? In the 135 degree course, that time you see there will be some deviation because of these poles. And again, when the vessel is on the 180 degree course, there will not be any Edwards ship HSI and there will be no deviation at all. And here we can see that we have got 2 to 5 degree course. That time there will be some deviation. And when the vessel is 270 degree course, no deviation. And when the vessel is 315 degree course, there will be some deviation. If we take this deviation and if we take this reading and put it in this graph, we can see that we'll get a graph like that, right? Here, this graph is completely opposite of the fore and aft continuous HSI graph, right? But both the graph follows the sine 2 theta curve, right? So it is so fore and aft continuous HSI and Edwards ship continuous HSI both are same, follow same curve but in the opposite direction. Now let us see what is the effect of VSI fore and aft, forward or aft above the compass, right? We know that the vertical soft iron is induced by jet, and the top of the VSI is usually considered to be the above and level of the compass position. Why? Because our most of the superstructure remains at the astern, and it remains on the aft of the compass, right? So if the vessel is on the northern hemisphere, we'll say that the aft, this VSI induced by jet will have blue pole on the uppermost side, and if the vessel is on the southern magnetic hemisphere, it will have red pole on the uppermost side, right? Now let us take the example of VSI induced by jet and the vessel is on the northern hemisphere. So if the vessel is on the northern hemisphere, we know that we'll have a blue pole at the astern and at the above the compass, right? So in that case, what will happen? This blue pole will have impact on our compass needle and it will act 4.5 direction, right? And when the vessel is on the 0 degree course, there will not be any deviation, but when the vessel will be on the 045 degree course, there will be some deviation, and the vessel is on the 090 degree course, there will be much more deviation, right? And again, when the vessel is on the 135 degree course, there will be some deviation, and when the vessel is 180 degree course, there will not be any deviation. However, again, the vessel is 225 degree course, there will feel some deviation, and when the vessel is on 270 degree course, there will not be any deviation at all. There will be maximum deviation. Sorry, apologies, right? And again, when the vessel is on the 315 degree course, there will be some deviation. So if we take this reading and if we put this reading into the graph, we can see that we're getting a graph like that. This graph, we call it as sine theta curve, right? So it is almost like P force, right? And now I want you to write down the properties of this deviation due to the induction by jet into VSI above the compass in northern hemisphere. What will be the property? The property is deviation is a semicircular deviation and the deviation varies as sine compass course. Okay, and we'll have in easterly heading we'll have westerly deviation, and westerly heading will have easterly deviation, right? So I want you in your personal notebook, please try to draw a curve for VSI above the compass in southern hemisphere, right? Once you have drawn that one, you can take a picture and put it in the comment, right? However, I have drawn it for you, and it will look like that, right? It is the same curve, sine theta curve, but it will look opposite, right? So we can see that for VSI above the compass in both the hemisphere will have sine theta curve, but in southern hemisphere it will have in one direction, and northern hemisphere it will have in another direction, right? Now the last soft iron, this VSI with a pole above or below the compass, and VSI will be induced by jet, and it will act through the compass position, and it will not cause any kind of deviation when the vessel is upright, right? This type of VSI will come into effect when the vessel will be heeled or least. So this thing will cover in the heeling error, right? So for our normal day-to-day condition, this type of VSI will not have any impact, and that's why we will not have any kind of graph for this VSI, right? So finally, we can, if we want to draw a table, or if you want to create a table for all the induced magnetism and their curve, we can get a table like that, right? So we can see that for 4.5 continuous HSI induced by jet, it will act in the forward and aft direction, and the deviation will be quadrantal, right? And the deviation will vary as sine to theta, right? And azimuth ship horizontal soft iron induced by H will act in the azimuth ship direction, and for this one also the deviation will be quadrantal. However, in that case, the sine to theta curve will be opposite of the fore and aft continuous HSI, right? And VSI induced by jet fore and above the compass will act in the fore and aft direction, but the deviation will be semicircular and it will follow the sine theta curve. And VSI with the pole above or below the compass, it will act in the top to bottom or bottom to top direction. When the vessel is upright, there will not be any deviation. I want you, please draw this curve in your own notebook and keep it ready for the coefficient. Thank you very much.